Welcome to our next tutorial on electricity. In this tutorial, I am going to discuss about application of Ohm's law in our daily life. We use Ohm's law in our daily life, but let me give you one example where we can really feel how it is working. Now first let us revisit what is Ohm's law. It says temperature remaining constant, rate of current flow or rate of flow of current through a conductor, through an electrical conductor, is directly proportional to the potential difference. And numerically we derived a formula V equal to I into R, where V is the potential difference, I is the flow of current, R is the resistance. Now here we are going to discuss, we will show one example where this Ohm's law is used. Everybody uses ceiling fan. Okay, I have pasted a picture of a ceiling fan, looks nice. And when you use ceiling fan, you always use a regulator, because through this regulator only you control the speed of a ceiling fan. Okay. Now, what actually is a regulator? Remember when we discussed about symbol of diagrams, we talked about variable resistance and fixed resistance. This regulator is nothing but a variable resistance. The different points in the regulator 1, 2, 3, 4, they are actually different values of resistance. Some regulators have a continuous motion, but some regulators have a discrete motion. Discrete means 1, 2, 3, 4, these are called discrete, and when it moves smoothly like your radio volume control, this is called continuous. And discrete means fixed values 1, 2, 3, 4, called discrete. Now regulator is a variable resistance, we call it as rheostat. Now what actually happens when you control your ceiling fan with a regulator? Okay, let me draw a small diagram of a fan, which is definitely does not look like a fan. Okay, so I have to always tell this is a fan, this is a fan, otherwise nobody will believe that this is a fan. But remember, but most important point is, when I increase the flow of current through this fan, the speed of the fan will increase, because this fan is working because of current flow. When I increase the flow of current, the speed of the fan will increase. Okay, and if I reduce the flow of current, the speed of the fan will decrease. The same principle is used in the regulator. Regulator has multiple points. The first one is a off, that means when the circuit is switched, circuit is off, that means no current, circuit will break here, that means no current will flow. Then comes point 1, that means it has a very high resistance, because in your regulator point 1 is when you want the fan to rotate at a low speed. So that means point number 1 in the regulator has a very high resistance, so the fan will rotate at a slow speed because current flow is reduced, so fan speed will be slow. Then comes point number 2. Here the resistance is slightly lower than that in point 1, therefore the fan speed will increase little bit more. Point number 3, the resistance is even lower, so the speed of the fan will be higher. And when it comes to the position called full, that means it has the lowest resistance. At the full position, the resistance is the lowest and the fan will rotate at the highest speed. So from now onwards, when you switch on your fan and you control with your regulator, just try to visualize it, try to build a picture in your mind that when you are at point 1 in the regulator, that means that the current is flowing through the highest resistance, that means the fan is getting low electricity. When it is at position full, that means the resistance is the lowest and fan is getting maximum current, so it is revolving at the highest speed. So this is one example of how Ohm's law is used in our daily life.